Hi there. Thank you for clicking on this lesson. In this lesson, we are going to talk about dividing radicals. Now, if you clicked on this video looking for operations on radicals in general, I do have a separate video that covers adding and subtracting radicals, as well as a video dedicated to multiplying radicals. Now, if you'd like to find those, they are on the radicals playlist on the channel, and I will go ahead and link the adding and subtracting video up there if that's what you're looking for. Please like and subscribe if you find this lesson helpful. Drop a comment to engage or ask a question, and check out the practice set for this lesson to see if you understand all of the things that we are about to go over. Now, I want to start with the reasoning behind this because dividing radicals is probably not the process that you might expect it to be. It is different. The reasoning behind it is different. The end product looks different. And I wanted to have a disclaimer right off the bat that we're going to restrict this discussion to square roots. And it's not because dividing radicals doesn't apply to any other kind of root or radical. Just the vast majority of times when you might be asked to do this, it'll be a square root. Now, if you are looking for a discussion with higher order roots and this lesson doesn't answer your questions or explain like the process behind it, which would apply to higher order roots, please leave a comment, ask that question, and I will do my best to help support you in whatever it is that you need for the class or the assignment that you're working on. Now, this is going to begin with what will probably feel like a bit of a detour. And we are going to ask the question, what is an irrational number? In English, the prefix "ir" means not. And so an irrational number is not rational. Now, that probably won't help you if you're not sure what a rational number is. There is a clue, though. Inside the word rational is the word ratio. And so a rational number is a number that can be written as a ratio, or frequently we'd say that it can be written as a fraction because we can write ratios as fractions. So a rational number is any number that could be written as a fraction. And that would clearly include numbers like 1/2 or 2/3. Okay, but it could also include, say, the number 4, because 4 could be written as 4/1 or maybe 8/2. If the number can be written as a fraction, then it is rational. Now, an irrational number, therefore, would be a number that cannot be written as a fraction. Like you can try plugging in all the numbers everywhere, but there won't be any numbers that can be written that would work as a fraction. So cannot be written as a fraction. Now, when it comes to examples, a common one is the number pi is not rational, but for the purposes of this lesson, it's most of your square roots. Okay, so the square root of 2 is irrational, the square root of 3 is irrational, not the square root of 4, because square root of 4 is a perfect square. So the square root of 4 is 2, which is rational, but it would be the square root of 5 and the square root of 6 and the square root of 7 and so forth. And so most of your square roots are irrational, meaning these radicals cannot be written as fractions. Okay, there are no integers that would give us that fractional equivalent. If it cannot be written as a fraction, then it does not have a reciprocal. So quick little review there. If a over b is the fraction, then the reciprocal would be b over a. And what we're saying here is something like this. The square root of 2 has no reciprocal. Okay, it does not exist because square root of 2 cannot be written as a fraction. Therefore, there is no reciprocal for it. What does that have to do with anything? Well, division can be defined as multiplying by the reciprocal. Okay. And early when I started the YouTube channel, I kind of started way back in what are operations on like the real numbers. And we go in and do a bit of a deeper dive into what is division in the first place. And there's a lot of ways you can visualize this with fraction bars or with dividing things into groups and different ways we can verbalize it. But typically by the time you get to around the pre-algebra, algebra 1, we really begin to think of division as multiplying by the reciprocal. So for example, if you have 5 divided by 1/2, okay, and just for the fraction connection on that, you can think of that as 5 divided by 1/2, meaning the 1/2 would be in the denominator. Okay, so you're doing that division. Well, that means it's 5 multiplied by the reciprocal. Well, the reciprocal of 1/2 is 2/1, and 5 times 2/1 is 10. And if you do not believe me, go pause the video, grab a calculator, and put into the calculator 5 divided by 1/2. Just go ahead and do that. And convince yourself that yes, that is actually 10. Okay, now that to kind of pull this all together, then since irrational numbers do not have reciprocals, we cannot divide by them. What that means is that something like 5 divided by the square root of 2 is not a thing. Okay, that is not an operation that can happen. Now you might say, well, wait a minute, I can go plug that into my calculator and my calculator doesn't error on me. It doesn't give me one of those domain error things. And that is because most calculators are going to change that square root of 2 over to a decimal approximation. Okay, and the moment you change it to a decimal approximation, then you are able to carry out the division. But the key word there is approximation. Some calculators will actually, if you try to do 5 divided by the square root of 2, it's going to give you some expression with a square root in it. And what the calculator is doing is the process that we're about to cover. So in terms of fractions, this means we cannot have a square root in the denominator of the fraction. So going back to this example right here, 5 divided by the square root of 2, if I were to write that using that notation, okay, we say, oh no. Okay, oh no, we cannot do 5 divided by the square root of 2. That square root of 2 is not allowed in the denominator. Division of radicals, which I know you've been waiting 8 minutes to get to, like, when are we going to divide the radicals? Okay, division of radicals typically involves a process called rationalizing the denominator. And in this case, rationalizing means to make rational the denominator. So if you have something like this where the denominator is irrational, we want to rewrite that so that the denominator is rational. So we rewrite fractions so that we no longer have square roots in the denominator. Now, all of that, I know I've been going on for 8.5 minutes. What that does is it supplies the rationale, not quite the same thing, but related word, the rationale or reasoning behind what we are about to do. So let's look at some simple examples. We've got the square root of 3 divided by the square root of 2. And by math rules, that is not a defined operation. Okay, just not a defined operation. You cannot divide by that square root. So we are going to try to rewrite that fraction into an equivalent fraction that does not have a square root in the denominator. Now, here's our key idea behind this. If I take the square root of 2 and I square it, the squaring and the square rooting undo each other and leave me with just the 2. So what I'm going to do over here is I'm going to square it, but I'm not going to do this, okay? Because that is going to obscure what we need to do to keep the fraction the same. So instead of writing the square root of 2 squared, I'm going to do this, square root of 2 times the square root of 2, which of course is the square root of 2 squared. Okay, but I'm going to write it that way. And the reason I'm doing that is because I have to preserve the fraction. I cannot come out with a different fraction with a different value. And in order to achieve that, whatever I multiply the denominator by, okay, in this case, the square root of 2, I have to multiply the numerator by the same thing, because the square root of 2 over the square root of 2 is equal to 1. Okay, so a little bit more reasoning, that's equal to 1. So what I'm doing there is I'm multiplying by the number 1. I'm not changing the value of the fraction at all. And now I am able to multiply straight across. The square root of 3 times the square root of 2 is the square root of 6. And the square root of 2 times the square root of 2 is, of course, the square root of 2 squared, or 2. You could also do this if you wanted to. Let me erase it. Like, you could get there this way. The square root of 2 times the square root of 2 is the square root of 4. And then that is the 2. Square root of 4 is 2. And so if you were to like plug these into a calculator, okay, so if you were to take this and put it into a calculator and this and put it into a calculator, you would get the same decimal value. Meaning we didn't change the value of the fraction. All we did was we rewrote the fraction into an equivalent fraction, which does not have the square root in the denominator. You might be wondering, well, why? Well, because mathematicians are picky about this sort of thing, okay? And they're really particular about the definition of division and what kind of a number we're trying to divide by and whether that is a possible thing. In a science field or an engineering field, you would probably just convert it all to a decimal and move on. And that's the difference in your disciplines. Your scientific disciplines are different in philosophy from your math disciplines. All right, next one below here, we're going to do the same thing. So if I want to get rid of the square root of 3, I need to square it. Okay, so here's my reasoning. The square root of 3 squared, the squaring and the square root would cancel each other out and leave me with a 3. But as before, I'm going to write it this way because I know I'm going to have to multiply by the number 1, which means that numerator will have to be multiplied by the same thing. The square root of 3 over the square root of 3 is 1. This will give me the square root of 30. And then you could just say the square root of 3 squared is 3, or you might do the square root of 9. Okay, and then say the square root of 9 is 3. Now, this we can actually go further. No, I don't think we can. I was going to say I think we can go further, but let's like double check that. 30, okay, if I wanted to simplify the square root of 30, I could do the prime factorization. So 30 factors into 5 times 6, and 6 factors into 3 times 2. So it's 5 times 3 times 2. I have no common factors, and so I am done. All right, those are like some of the simpler ones. Okay, you just have a square root in the denominator and you need to rationalize it. What happens if you have a more complicated denominator? So if you have a denominator that looks like this, then you may need to use conjugates to rewrite the division. And if you don't recall, we'll do a quick little review of conjugates. Conjugates are when you have, say, a plus b and an a minus b. These two things would be called conjugates of each other. You have the same factor terms, but opposite signs. And the important thing about conjugates is when you multiply them, you eliminate the middle term, okay, when you multiply them. So what I do here is I look at the denominator. And the problem with this is that I have a square root in the denominator. That's the issue. And we're not allowed to divide by that irrational number. And so I look at the entire denominator and I say, okay, the conjugate of that would be 1 minus the square root of 3. And as before, I need to multiply the numerator by the same thing, because anything divided by itself is 1. And so we're not changing the value of the function or expression. Now, this is going to require a little bit of scratch work. What I'm going to do over here is multiply the denominators together. So I'm going to have 1 plus the square root of 3 and 1 minus the square root of 3. 1 times 1 is 1. 1 times the square root of 3 is the square root of 3. 1 times negative root 3 is negative root 3. And negative root 3 times root 3 is negative root 9. Notice that the middle terms cancel each other out. That's what we were going for. And then the last term, because you are essentially squaring it, would be 1 minus the square root of 9, but the square root of 9 is 3. So all of that becomes negative 2. And so my denominator has been rationalized. I have gotten it to a rational number, which is the negative 2. Then your numerator, that's going to be just straight distribution. And so root 3 times 1 is root 3 minus the square root of 9, so root 3 minus 3. And you might leave it as root 3 minus 3. I think I would tend to leave it that way unless I was told to do something else with it. Somebody might want you to do this, negative 3 plus root 3 over 2. So they might just want the order, like the original order preserved. You could also see something like this, negative 3 over 2 plus root 3 over 2. So all of those could be ways that you could see it, or we could do that splitting up. Oh, sorry, I dropped my negative here. Yeah, and right here, I guess like right there, okay, you could cancel that out, and because a negative divided by a negative would give you a positive, but there you go. Okay, so how you want to leave the answer kind of up to you and the requirements of your particular course. Is this like a pain in the neck process? Yeah. And it's very unique to mathematicians. Like this is the kind of thing that is kind of like an exercise in rewriting something that is unique to a math class. One final example, just so we can make sure we cover all the bases. So we have 2 plus root 3 over 3 minus root 5. And of course, the problem is the root 5 in the denominator. And so we're going to go to the conjugate. That'll be 3 plus root 5. And you got to make sure you multiply the numerator by the same thing. I'm going to do my scratch work off to the side. So we have 2 plus root 3 times 3 plus root 5. So that's 6. Then we have 3 root 3 and 2 root 5, and root 3 times root 5 is root 15. None of that matches. So we don't have any like radicals. If you're unsure what to do with that, please go back to the beginning of this video where I linked in the adding and subtracting. I'll probably try to link it in the description box as well. If you want to go find that video, if you're like, wait a minute, why isn't she adding all that stuff together? Okay, that probably warrants a review. Oh, that's a 15. And then we need to do the conjugates. So we have 3 minus root 5 and 3 plus root 5. So this is 9 minus 3 root 5 plus 3 root 5, that's why we're doing it. I want that to happen. Minus root 25. These guys cancel out. Okay, again, that was the point. And so we're left with 9 minus root 25, which is 5, and all of that becomes a 4. And then from here, you might want to see if there's something that cancels out, like do you have a common factor with something in the numerator? Maybe they're all even numbers. Now in this case, it's not. We don't really have anything that cancels out. None of those radicals simplify. So that's as far as we can go, but you would want to check to see if there were some simplification steps so you could make stuff look a little bit nicer. One quick thing before we head to the practice set. Recall that the imaginary number is the square root of -1. So what that means is if you have something like 4 over 3i, that is another oh no situation, because what that really is a radical. Okay, you have that square root. And so you have the option of handling your imaginary and complex numbers in the same way. Okay, so Please don't forget to give this video a thumbs up if you found it helpful. Subscribe to the channel for more math content, drop a comment or ask a question, and check out the practice set for this material, which you should see linked below so you can see how well you understood the concepts in this lesson. And I hope to see you in a future video.